Hello folks, and today we'll be starting the detailed video explanation of CBSE Class 11, Chapter 2, that is a Boolean Logic. And this Boolean Logic will be studying about this. Uh, what are these Boolean variables and expressions? Boolean operators will be learning about, like your and, or, not. These are the basic ones. Derived ones like NAND, NOR, XOR. We'll be learning the truth tables, how to make. What is the laws of Boolean algebra? The most important De Morgan law, there is the first law, the second law. Logic gates will be studying about. Some universal gate, that is NAND and NOR gate, will be studying. Logic circuits I'll be evaluating, making gate comparison table, chapter summary, what are the common mistakes we make and we should not make it, important questions, mnemonics to remember up things and relate things with real life examples will be covering in this video. So stay tuned for the whole video, right? And in the comments or in the description box you will get the notes and notes in the PDF Google Doc PDF will be getting. So yeah, stay tuned and watch the whole video as we'll be covering it. So let's understand what is a Boolean logic. Boolean logic is basically a branch of mathematics that deals with binary variables, binary language that can only hold two values and does all the mathematical operations in that. That's the true, and that stands for 1, and 0, that stands for your false. So we can relate it with a switch, that is on or off, or the high voltage or low voltage. We can relate it with that. And it was developed by your English mathematician and logician George Boole in the mid 19th century, and he created a system known as Boolean algebra. So this Boolean algebra works only with two values, 0 and 1, and it can represent many real world binary states here. All the logical circuits, all the semiconductor indicator circuit chips, mobile devices, any chips that is done using this two things, 0 and 1, only this two binary language system, unlike your ordinary algebra that deals with decimal number system of 0 to 9, 10 digits. But here we only have the two digits, as we know that, right? So every decision your computer makes, that is a loading a web page, it becomes a running a program, storing a data, checking a password, is all depends upon this Boolean logic. Billions of transistors inside a processor are nothing but tiny electronic switches that are either in on state or either in off state. On is represented by 1 and off is by 0. We know this. The three components of Boolean algebra contains Boolean variables, expressions, operators. Variables are those things that hold your true or false values, or the 0 and 1 values. And expressions are a combination of these variables with operators. When these are the operands, there are certain operators to become an expression or the operation at end. Right? And operators are the and or not, these are basic. Others are there like nor are there, NAND is there, NOR is there. We'll be covering this in the syllabus that is there now. In the class 11 we'll be studying this. So let's start with Boolean variables. So like a is equal to 1, let's assign b is equal to 0, then this are false. We can represent this by your single capital letters like uppercase letters a b c x y g, anything. Or you can represent a variable, let's say is logged in equal to true. So these we'll use in programming, other things like that. So it can only be in the on state or off state. There's no half state or intermediate state in between. So you can think like that. And then proceeding ahead to the Boolean expression. The Boolean expression, a combination of these Boolean variables, the Boolean values, the Boolean operators. Every Boolean expression evaluates ultimately to either true or 1, false or 0. Every Boolean operation. There's an operator, there are some operands to do this operation. Right. So what is the most commonly used? And operator. We'll see or operator, the not or the complement inverter one, and some expressions will be seeing it. So yeah, so let's discuss with the and operator. This and operator or the and gate, later will be seen the logic gates will be how it is done. It is known as the logical multiplication. Logical multiplication, and it is commonly represented in the dot operator. like A dot B, right? And gives output 1 only when all inputs are 1, like 1 dot 1 is 1. Even if 1 is 0 here, it is 1 here, but here it is 0, it will give 0. 0 dot 0 is 0. 0 so you can remember like this. How you can remember the whole table? 0 dot 0 equal to 0. 0 dot 1, even if 1 is 0, it will give 0. 1 dot 0, even if 1 is 0, it will give 0. 1 dot 1, when both are true or both are 1, it will give 1 finally. All and nothing, that's a memory thing. All and nothing, if everything correct is correct, if 1 is false, it's gonna be wrong, right? You can relate this with this example, or this is just example. जैसे कि you need to board a flight, you need a ticket, you need a means a boarding pass, you need it, and you need an identity card. If either is missing, we're not allowed, like this, something like that. We can understand like this. Then coming to the or operator. Or operator is represented in a plus sign or the plus operator. It is known as a logical addition. Logical addition, it is known as here. And A plus B test. Here it works opposite to that of a AND gate or the AND rule. When OR gives output 1 only if any is 1. So you will see this is 1 here, this is 1 here, here both is something. Something is 1, it will give 1. Something is 1, it will give 1. Both are 1, it will still give 1. If one is both are 0, it will give 0. So you can remember like at least one. All needs just one to say yes. Like a team relay, anyone finishing is enough in that relay race. Or you can enter in club, you can remember using this real life example. Let's say you have this pass, VIP pass, or you have the celebrity status. Having one is either one is enough, and then you can enter it. So that is the OR operator, right? And then we got the NOT operator. NOT operator is you can known as a complement or the inverter also. Inverter or the inversion. It represents in a complement. There are actually three things. A is a bar you can get, or like this you can also represent. Most common is this representation. It is a complement, right? Now how you can relate it? Not reverses the input. 0 becomes 1 and 1 becomes 0. It is the only unary operator that takes one input. Because in the previous things, a light toggle button on the opposite machine you can relate. In the previous things, there are two operators that is needed, right? The slide up and see here, there's a A, there's a B. There are two operands needed to perform that operation. Here in and also there are two operands needed. But in here there is only one operand is needed. That is why and OR are binary operators. They need two or more inputs. They can be even be more. They can be also be three A, B, C. They can be also. We can evaluate this. And not as a unary operator. It takes only one input. Sometimes this asks MCQ question. So be careful with this. Then truth table. Truth table, that is for A, B, C or A, B or A simple. That is a truth table. Basically it's a tabular representation and list all possible combinations of input and the corresponding output values for a Boolean expression. And what is the formula there? 2 to the power n. N is the number of input variables or the operands. Just like this, जैसे कि in your NOT gate is only one operand. They will give 2 to the power 1, that is 2 number of rows. And here it is written A, right? A. So there is only 2 rows, 1 and 2. But in your and or get example, we saw there are two, minimum two. We can also take three. Like A is there and B is there to perform something at the end, right? So two square we take and total is 4 rows. Like that gives here 1, 2, 3, 4 rows, right? Here. Like that it can also be 3. Let's say we need A, B, C. Minimum is 2, maximum can be anything. So it will give 2 cube, 8. Total is 8 rows it will come and 8 values are there. And maybe fourth it's gonna be 16 like this. This is a table here for the reference, and remember using this formula, right? And don't make the mistakes. and this is a systematic pattern. Then there are certain laws of Boolean algebra. The most important is your this De Morgan's one. Other just laws that might come in MCQ question. Let's figure this out, and what are these? Let's learn this. First is idempotent law. Sorry, identity law. Identity law, operating with the identity elements, keep the variable back. In the AND version and the OR version we're discussing. जैसे कि 1 dot A is A and 0 plus A equal to A, we have to remember. There is a null and dominant law. Here 0 dot A is 0, 1 plus A is 1. Operating with the dominant element forces a result. Then the idempotent law. A dot A is A and A plus A is A. And ordering a variable itself gives the same variable in back. Inverse law. A dot A complement is 0 and A plus A complement is 1. Commutative law. This is basic maths commutative associative distributive. AB equal to A plus B equal to B plus A. Associative law. A into B whole into C gives A into B into C whole. In OR version, in the logical addition, A plus B whole plus C is equal to A plus B plus C. We know this grouping doesn't affect the result. In commutative law, order of operands doesn't matter. In distributive law, A plus B into C is A plus B into A plus C. We know this right from maths. And OR version, A dot B plus C is AB plus AC, distribution over the other operation. We know this, right? And then is a absorption law. Absorption law, like A plus B, like it absorbs, one time absorbs other and gives A plus AB gives A, one time absorbs other. Most important little study here is your this one, De Morgan's law. That is A dot B complement, it is actually it is A dot B whole complement equal to A complement plus B complement. This is De Morgan's first law. This is De Morgan's second law also. In the OR version, that is A plus B whole complement equal to A complement dot B complement. So these two laws we need to remember, and these are the very important for examination point of view. Okay, so remember what is the thing, you have to just break the line and change the sign, right? And changes to or changes to and, each variable gets its own complement. This is a De Morgan's first law. What is De Morgan's first law? A dot B whole complement equal to A complement plus B complement. In words, the complement of and equals the or of individual complement. This is a whole thing and this is a separate thing. Means if you negate an AND operation, you get an OR of the individual complements. These are truth table verification. A complement, B complement, and A dot B is here. A dot B whole complement and A dot B complement. So this is, you can use it to verify it. That this is 0 0 0 1 1 0 and 1 1. And what it becomes for the A complement, what it becomes a B complement. What we do is A dot B whole complement equal to A is become the same for A complement plus B complement. This you can verify on your own in this table, because we know how to do the AND operation, we know how to do NOT operation, we know how to do the OR operation, right? Isn't it? You can calculate like that, isn't it? There is a De Morgan's second law. Here the A plus B whole complement equal to A complement dot B complement. Like that we can also do the truth table verification here. And the meaning in words is the complement of OR equals the AND of individual components. Meaning if you negate an OR operation, you get an AND of the individual complements. So we can do the truth table like this. In this proving the law, sometimes in exams it might become. So we can do this, right? So Extended De Morgan's law. These are the extended law. Sometimes it is written and may be asked. This can be extended to any number of variables. So we can extend, let's say, three variables. Extended first law is how? A dot B dot C whole complement is A complement plus B complement plus C complement. We can extend it. Extended second law is A plus B plus C whole complement is A the complement dot B complement dot C complement. We can do it. So this is a quick exam shortcut. Complement the entire space and put a bar over it. Change all and to or and all odd to and complement each individual variable. That's the whole thing, right? So logic gates. Then we go over the logic gates. What is a logic gate? Basically, logic gate in physics also it might come later in somewhere in class 12 or something. It is now deleted as part of the new NCERT pattern. So a logic gate is an electronic device that performs a Boolean logical operation or one or more binary inputs 0 or 1 and produces a single binary input 0 or 1. And these are the building blocks of all your digital electronic circuits. The main are six logic gates that is in syllabus for class 11. Not and or, these are the basic one. NAND and NOR are the universal gates. We can make any gates using these two gates. There is a XOR or the exclusive OR gate. Let's start discussing with the NOT gate, the easiest gate actually. The NOT gate is represented using this sign. There's a triangle and there's a bubble. This is a negate. So if you pass an A here, it becomes A complement. It's 0 to 1 and 1 to 0. Small bubble at the output gate represent the inversion of the complementing. This will see also in NAND gate and NOR gate. You'll be seeing this bubble part. So remember the diagram how it is done. Then it is your AND gate. AND gate is using this uh, kind of this symbol. There's a rectangle and there's a some house type of structure here. And when passing two operands, it's a binary operation. A B then gives A dot B. D shaped it is basically, right? And we know how to do it. 0 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, 1 dot 1 is 1, and everything is 1. It gives 1. Even if 1 is 0, it will give 0, right? There is a OR gate. Or gate is like curved shield type of structure you can draw. So if you pass in A here, you pass in B here, it will give you A plus B. We know the rule. If even if 1 is 1, it will give 1. Both are 0, it will give 0. The opposite of your AND gate is OR gate. The other basic gate is mentioned. There is a NAND gate. NAND gate is a universal gate. What is a universal gate? NAND gate and NOR gate are universal gate, meaning we can create any of the gates using the two gates, NAND and NOR. NAND is basically a combination of what? Not plus and. That is why you can see there's an AND gate and there's a bubble to negate or the complement. We're passing A, we're passing B. Normally it happens A dot B. Here it negates or complement. You do the whole complement here. Simple. And how does it works here? 0 dot 0, A dot B is 0. The A dot B whole complement is what? 1. 0 dot 1. So A dot 0 is what? 0. And it is now if you do the complement of 0 is just 1. Now 1 dot 0 is how much? 0, right? Even if 1 is 0, it will become 0. So 0 ka its complement is 1. When both are 1, it becomes 1 and that complement is 0, right? That is nearly always 1, right? You can remember like this. NOR gate is the same thing. It's a combination of your OR gate plus NOT gate, right? You can create this like this. You can create and you get A, you get B, and you get A plus B. A whole complement. This negates the thing, right? And how this works? Nobody equal to 1. Like 0 plus 0, you get, when everything is 0, here it is 0, and if you do the complement of this, it becomes 1. And even in the normal OR gate, even if 1 is 1, it will give 1. 0 plus 1 is 1, negated 0. 1 plus 0 is 1, negative 0. 1 plus 1 is 1, negative 0. Like that it works, right? There is a XOR gate or the exclusive OR gate. How do you draw this? You do this curved sealed, and here you do this, and then write a curved line. It's a and B, it gives this sign. The operator is a plus. It is not this, so it is exclusive around a circle around it, and B, exclusive OR. And how this works? If two digits are, like you can see it here, if two digits A 1 and 1 or 0 or 0, if they are same, it will return 0. If it is 0 or 1 or 1 or 0, it will be in 1. 1 when different, 0 when same. So as a difference detector, lights up when the inputs disagree. Right, you can remember like this. So universal gates that we discussed, they are like, these are the gates that can be used to implement any Boolean expression and can be used to construct all other logic gates like AND, OR, NOT, and XOR by themselves. The both NAND and NOR are your universal gates. Universal gates are like a Swiss Army knife for digital electronics, just like a Swiss Army knife, and replace many individual tools. It's a NAND and NOR can replace all other gates. So within that NAND and NOR gate, you can build anything. Let's say. So this is the answer. Exams you might write. XOR is not a universal gate. That is wrong. Only the NAND and NOR. Don't get confused with that. There's mistake here. There's a logic circuit. What is a logic circuit? Logic circuit is an electronic circuit that performs logical operations on a Boolean input variables and produces Boolean outputs using a combination of logic gates connected together, and the signal flow goes from left is the inputs, right is the output. Each gate processes its own input and sends the output to the next gate. Like that we evaluate it. So uh, let's set logical expression. This example, we have three gates. We have three inputs. Let's say A, B, and C in the example number 1. A and B enter a NAND gate. So A and B enter a NAND gate. So it will give the output A dot B whole complement. C enters the NOT gate. That will give you a C complement, right? So outputs A dot B complement, B and C complement, and a final enter a AND gate. Then the output is, it will give Y. How it gives Y? See, A dot B complement NAND gate, NOT gate C complement, and A dot B whole complement B and C complement. Output is A dot B whole complement dot B dot C complement. It is a final answer that we relate. Then is a draw the logic circuit for this. So you can draw some logic circuits like given steps. And I think it will be in the notes how the diagram is there and how we actually do this. So we will not be covering it here. It will be given the notes and diagram. In the intro video also we discussed that diagram structure. That is one diagram structure might come. So that's all for now. And yeah, logic gates are this comparison. You can see. So remember all the things. This is a whole gate comparison table. You can take a screenshot of these things. And gate shapes are there to remember how it is difficult to draw. You can take a screenshot. Remember this. It will be given the notes, everything in detail, the summary also. So what we learned today, we learned the Boolean logic, right? It works with two values, 0 and 1, true and false, developed by George Boole. We learned about Boolean variable represented by any uppercase letter like A, B, C, X, Y, G, anything. It holds only two values, either 0 or either 1, that stands for true or false. The AND operator, dot operator, the logical multiplication, all inputs must be 1 for the output to be 1. Even if 1 is 0, output is 0. OR operator, the logical addition, or the plus operator, we discuss any one input being 1 makes output 1. Everything is 0, the end is 0. Right? Not is the inverter, unary operator, and an or a binary operator, right, is a complementer, not also. Truth table 2 to the power n, we can calculate like 2 variable is 4 rows, 3 variable 8 rows. The truth table we have to make sometimes, so that is the thing. Then other laws are there, but most important, De Morgan's first law, we discuss a dot b whole complement equal to a complement plus b complement, that is a complement of and together is or of complements individual. And De Morgan's second law is a plus b whole complement equal to a complement dot b complement. Complement of odd together gives individual and of complements. There is a NAND and NOR a universal gate, that is NAND output 0 only when all inputs are 1, opposite of AND gate. NOR is your output 1 only when all inputs are 0, opposite of OR gate. NAND is a combination of NOT plus and NOR is NOT plus OR, and so is exclusive OR. This is not a universal gate, and outputs 1 only when inputs are different, outputs 0 when inputs are same. We know that. Logic circuit, how to make it, how to evaluate it, this further will be covered in the notes, the detail. De Morgan's trick we learned it, um, and how to evaluate the Boolean expressions later. And these all are the truth tables. You can take the steps. Sideways check, quick reference, you can take the screenshot of this, right? As the whole thing. And yeah, so these are some high priority topics that might be asked. Some medium priority topics might be asked. And these are some might be some important board exams question, not board exam but the school exams, because there are no boards in 11th and it will not come in 12th. These are not part of the board exam syllabus actually. Don't get confused with some common mistakes. You can see it here, what is the glimpse, you can take it. And that's all. We'll be getting the notes in the description or the comment section, the Google Doc link. So next we'll be covering the chapter 3. Chapter 3 I think is number system, we'll be discussing, right? And the encoding schemes, ASCII, scheme, Unicode, 4 types of number, hexadecimal, decimal, octal, binary will be, and the conversions will be seeing later in the chapter 3 probably I think. So that's all for now, and thank you folks for watching this. Hope you understood something from today, and stay out there for the next video. So yeah, that's all. Bye bye.